So have you ever put cam bearings in a Mopar block and had the cam spin on the first try?
I've had more times that they didn't spin on the first try.
Or at all?
Yeah, or at all.
Okay. Why are they tough like that?
I don't know this for fact, but I've always heard that maybe the cam bearings were installed, rough fit cam bearings were installed in the blocks, and then they were line bored to fit after the cam bearings were in. I don't know if that's true or not, but it just seems like Chryslers always give trouble, and it doesn't matter which one it is. Small blocks, big blocks, they all give trouble getting the cam bearings to fit.
Yeah. So this is what's going to be a 483 cubic inch stroker engine that we're building for Scanner Danner. We've gone through and done all of the machine work here, a lot of custom work, bushings in the lifter bores. I did a bunch of kind of de-shrouding / clearancing for our aluminum heads that we're going to be using. It's way bored out because this started as a 413 block that was, what, 418?
4187, I think.
Yeah, 4187 bore, and now it's 4255. But yeah, we got to get cam bearings in it and see if they fit, and if not.
What are you going to do if the cam bearings won't fit at this point at all?
If they don't fit at all, I guess we find somebody to outsource boring the cam tunnel to. So, but let's get into it. I'm going to lower the desk down here. Workbench / desk.
Yeah, desk one day, workbench the next.
Because this is a freaking heavy block. You want to get on that side and help me?
Get more back in the middle.
How heavy is that thing? 200?
Probably close to it.
Guess we could get the scale out and weigh it.
Yeah.
Okay.
It's heavier than a
I've
small block Chevy.
Yeah, I knew that much. Got the cam here, got our cam bearings. Let's get our installer out and see if we can
make it work.
Yeah. Okay, so we need that. This. The nice thing that Chrysler did is made all of them a different size, so you have to have different size tool to...
A different driver for every single one?
Different driver for every one.
It looks like they're kind of relieved on the front side here.
Okay.
So they'll go in easier from the front.
Okay. The back one we'll probably just have to do from this side.
Yeah, go ahead and pull it in from the back. I don't know if you can see that right on this front edge. It's been slightly counterbored, so the cam bearing will start back in easier if we put them in from the front. Move up to that next one, maybe you can see it better. That one there, maybe it's a little more obvious on the camera.
Okay.
So let's take advantage of that. We need all the help we can get doing Chrysler cam bearings.
Okay. Do you want to do it down here, or do you want to raise this thing up and...
Well, I'm kind of short,
Yeah.
So don't make it too high.
Well, let's just see how high it'll go. Well, as you can see, the desk can go pretty high. This is actually a standing desk, and this video is sponsored by Flexispot. And it's pretty stable with a 200-pound block on there. But I don't think we want to work with it that high today. Let's go ahead and lower it back down. And
Normal workbench height.
yeah. They sent this out to us to use. I thought it'd be awesome for doing cam bearings here because we can work with it down low where it's easy to reach. And then if we need to, we can tilt things up and get it up more at eye level, a little bit easier to work on than just at the bench. With the Flexispot E7 Plus, you get a high-quality 4-leg standing desk at a reasonable price. A standing desk like this gives me the flexibility to go from a comfortable seated position when it's convenient to settle in and work to a standing position that makes it easy to go back and forth from my computer to another workbench or a machine nearby without having to bend over or crouch down to reach the keyboard. With a few customizable height presets, you can make the switch on the fly. It's highly adaptable to your needs and preferences with accessories like laptop docking stations, external monitor mounts, and wheels for mobility in an environment like I use it. And who knows, maybe you even want to use it in a bit more rugged environment as a workbench like this, and trust me, it can handle it with a 540-pound static capacity and a 440-pound lifting capacity. This block is over 220 pounds and I'm about 215, so together we're pushing the 440-pound lifting limit and it handled it like a champ. FlexiSpot is having their amazing brand day sale, so don't miss out. FlexiSpot provides all kinds of standing desks to meet your demands. If you prefer a rock-solid stability standing desk, then the E7 Plus is your top choice. If you want a premium standing desk for daily use, you can check out their E7 and E7 Pro C-Frame. If you're on a limited budget, you can choose their E5 model. Unlock more savings by using the exclusive promo code provided in the description and click the FlexiSpot link to enjoy these fantastic discounts in May. We're going to start with putting the back cam bearing in, see how that goes. So there's one oil hole.
Yeah, straight down from the top.
Okay.
You know, every video lately, I've had a bandage on one of my fingers.
This kind of a constant problem, ain't it?
Well, this morning I stuck my finger somewhere it shouldn't have been and about took the end of it off.
Think about like that?
Yeah. So now what we need, the washer and nut on there?
Probably a washer and a nut. The theme of this channel is two people doing one-man jobs.
And making it as difficult as we can.
Yeah. Okay. So we have that mark there for that oil hole. There's only one oil hole in these blocks, but it's pretty important where it goes because there's no groove
Right.
on the back of the cam bearing or on the block itself
Right.
here.
So it has to be lined up.
It's got the centering cone here, so hopefully this is going to pull that cam bearing in nice and square. Are we going?
Yeah, it started in. Yeah, I think usually
Pretty
they're
far on the
almost,
bottom.
yeah, they're usually almost flush. Stop.
Could maybe go forward just a little bit, but let's take it off. And
Okay.
do you think it should go a little
Yeah,
more?
it needs to go just a little bit more.
Okay.
If you look down in this way.
I have no idea if you'll be able to get the camera to show this, but if you look down through that hole, maybe you can see that it's not quite lined up, needs to go forward a little bit more. Ready?
Yep.
How much you think?
Just a little more. There.
Okay.
You know, these holes, when they're drilled in the blocks, they are not exact. And that's why they're so large, is that way if things are not lined up perfectly, there's still plenty of room for oil to go through. And I'm going to say stop right there, because if we go any further, we're going to be hanging over on the inside here.
Okay.
Even though if I look down through there, it looks like it could stand to be just a little bit more to line the hole up perfectly. But there's still,
There's still enough.
oh, there's a 1/4 of an inch diameter down through there.
If anything, I probably rotated it ever
Yeah,
so slightly
yeah,
this way too.
it's slightly rotated off just a little.
So the rest we'll do from the back side, since they have that leading
Yeah.
counterbore, essentially.
Do we want to slip the cam in that very first bearing and see if it's going to fit? Or we go any farther, being this is a Chrysler. Looks nice. See right there, already the first one won't go in.
Are you serious?
I'm serious. There it goes. Maybe I just wasn't lined up quite right. Yeah, it's okay.
Okay.
Why don't we start at the front and just keep working our way to the back?
Whatever you want to do. I thought I understood you to go that way, so.
No, listen to what I'm thinking, not what I'm saying.
Yeah. That's what I'm used to. Okay, well, get me cam bearing number 1 then.
Okay. Okay, so the front one, we only have the one oil hole.
Straight up.
Yeah.
Well, down.
Yeah, straight down, straight up, whichever way we're looking at it from.
Is it going?
Yep, it's going in. Just slightly below flush is where I believe it
Okay,
stops
you'll
at.
have to tell me when.
Just a little bit more. Let's take a look at it, see what that looks like.
If anything, it looks like it could go back slightly.
Well, that's what I'm thinking.
Okay.
Let's stop there.
That looks good there.
Yeah, you're in a good spot. Should we try the cam again?
Yeah.
Those are close, but it does go. Yeah, it'll be fine. Put at least one more, and maybe we'll test it. I feel like if the front is okay and the back is okay, we would probably be able to put the cam in as it is, because when you get in trouble is when you put the next one in, and the next one, and the next one, and they're like a snake through the block.
Right.
So they're either out of alignment with each other or a little bit too tight.
I understand what you're saying. I just am picturing if their tooling could have flexed or something, boring the tunnel in the block, you could still have the front and the back be somewhat aligned and
Yeah. Yeah, I see what you're
potentially be
saying.
off. But I'll be optimistic with you that if we have
Everything's
the
gonna
front
fit.
and back, we're going to be good.
Okay.
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 Trying to get it lined up as well as I can. Okay, now I can put one of these long spacers on, and a short one, and another short one, and the nut. That's going in nice.
Yeah, that. Tell me when.
Yeah, let's stop right there. See what it looks like. Ouch, that's my Band-Aid in there.
Well, that's what I'm like. What the Get your dang fingers out of the way.
It started pulling the edge of that Band-Aid in with it. That's twice
You notice
today.
how I keep saying Band-Aid when it's a piece of friggin' tape?
No, that
Is it a Band-Aid?
Yeah, it's a regular,
Okay.
one of those butterfly ones or
It
whatever
looked
they
like
call them.
masking tape on there.
I think we're in a good spot.
Okay, you want to test the cam?
I hate dragging the cam through the cam bearings
Okay.
that many times. Well, let me finish. I hate dragging it through that many times, but let's try it. With as many times as we're going to have this in and out of there testing it, I'm just going to put a little electrical tape around the journals or around the cam lobes here and see if we can keep from scratching our cam bearings. Hey,
It's in. So how tight is it?
it's not.
Oh, wow.
All right, I'm going to go get a couple of 5/16 bolts to screw in there for a handle. Be
Okay.
right back.
Alrighty. But yeah, the cam turns really nicely. I mean, you can turn it there on the front. That's awesome.
I went and grabbed the wrong size bolts. I grabbed 5/16. I guess these are 3/8. But anyway, I'll use those for a handle in there anyway.
Ding, ding, ding. That's like a 6-year-old kid's birthday party with the bumpers on the bowling lanes.
Yeah, balls back and forth.
Yeah. Actually, I think we did pretty good.
Yeah,
Okay.
yeah, those look fine yet. Whoops.
What's your 2 cents? I say we put the other 2 in and
And not even try again? Nah, I want to do them one at a time.
all right.
I want to know which one it is that bothers, because when you get one that's tight and
Yeah.
they're all different sizes, you have no idea
Oh.
which one it is.
Yeah.
Okay, so we're ready for number
He
3.
never likes my ideas. Actually, you do like some of my ideas.
I do like your ideas.
Just not these ones.
You
guess I
have
could pull that up.
come up with some good ideas of different things that I've been doing wrong all these years.
I can't see, so
A
you
little
gotta tell
more.
me.
Keep going. Right there. Let's see what that looks like.
Okay, ready?
Yep.
I'd probably leave it.
Yeah.
Because you go much further back this way, and it's...
It starts hanging out on the backside. Okay, you guys gonna make fun of me shaking again?
What do you... When do you want me to grab it?
Whenever, because it was kind of caught on my hand. I couldn't keep it going. We should invent a tool that you go in from the back end with a cone to center it and a pin that goes in the back end of that cam, and you could just guide that thing right through. But we won't do that today.
Tight?
Yeah. But not terrible tight. I would not be afraid to run that.
Okay. progressively gotten a little tighter.
Yeah, but we're not bad yet. Still feeling good. Now this one's going to be a little bit harder because we have to get both of these holes lined up along with the one that comes from the mains.
Okay. Do you want to put any marks on it so we can see, or?
No, I think we can, as we're starting there, I think we'll be able to see where the hole is.
Okay.
Okay, I'm going to say go for it.
Okay, you're still happy with where it's at?
Yep. One more. Stop. I'd say we're probably about it.
See, I think it's just this hole is a little bit further back than the other two.
Yeah.
But
Yes, those are rough drilled. You'll never have all three of them line up
exactly the same.
perfect. You just got to make the best of.
But I think
what
it's in
you
a
have.
pretty good spot.
Yeah, I do too.
Okay.
I hate to do this to you, but let's pull it just a teeny tiny bit more. This hole here could line up a little bit better, and the what would be the left bank could line up quite a bit better.
Okay.
And that bank is perfect right now, but it'll, be the happy medium between. That's enough. Okay, let's put the cam in, see how it feels, and also look and see how the spacing of the cam bearings are compared to the journals on the cam. Okay, get your fingers out. Yeah, it's gonna get snug on us. Typical Chrysler.
Okay. Now we go to plan B.
Yeah.
So plan B, something I've also seen on the internet that people are doing, is kind of making almost like a ball brooch to kind of push through and hopefully take down the high spots on the cam bearings. And
Well, I think, doesn't it kind of swedge the cam bearing out tighter into the block,
yeah,
which is going to be a good thing, because it's just a little too tight. Yeah, because I'm at the point now, the cam will go in, but I can't turn it freely by hand. Are you going to do all of them, or just the ones that you thought were tight?
do we start with these two, since these two are where it got tight?
That's what I'm thinking.
Almost start with this one, see what it does.
Yeah.
And then that one.
Yeah.
Again, it's a pain because they're different sizes.
It's a pain the first time, and then we'll have the tool for the next time.
But I don't know what we're ever going to do with that lathe.
No, nothing at all to use it for.
Plan A didn't work, so now we go to plan B.
Yeah.
Alrighty. Okay, so a couple days have gone by. We got all the cam bearings in the block, and surprise, surprise, it doesn't turn. This is something that I've been expecting the entire, time of working on this block. I mean, one thing you can do is go straight to boring the cam tunnel of the block to get them all perfectly aligned, and then putting oversized OD bearings in. We don't have the capability to do that, and it's just an added expense and added time. Another thing that people have found success with is kind of making a brooch, if you will, and pulling or driving a broach through the tight cam bearings, and hopefully, pushing out
Swedging them out. It's probably
Yeah.
more of a swedge than a broach, because a broach, probably terminology would be removing material,
Yeah, maybe.
where swedge, we're displacing material.
Yeah. So hopefully that'll kind of displace the high spots and go through these two bearings and maybe get the cam to where it'll turn without having to intervene a little more. I don't know.
Not quite as aggressive
Yeah,
approach to
not
doing it.
as aggressive, not as time consuming, not as expensive. So I've got the nominal camshaft diameters pulled up here. The bearings that were tight were number 3 and number 4. This is the diameter of the actual lobe, well, not lobe, the what do you call it? Journal on the camshaft. Journal number 3, 1.967 to 1.968 inches. From people that I've talked to doing this, they said to shoot for about 3 thousandths bigger than the nominal diameter, because the journal oil clearance is supposed to be 1 to 3 thousandths. So I'm going to start with this 1.967, and we're going to turn out a piece of steel that is that 3 thousandths larger. And I've actually kind of drawn it up here. This is our plan anyway. So this is a 2-inch long piece of steel, and this 1/2-inch section here, you can't really tell, but if I zoom way in here, it actually has a little bit of a crown to it. You can see from here to here, and this point right here in the center is where we're going to be that about 3 thousandths larger diameter than the nominal shaft size. On the edges here, I'm actually about 2 thousandths smaller than the nominal size, and the reason being we're hoping that that will kind of help it pilot to get straight in the bearing, and then we'll be able to pull it on through and hopefully, kind of swedge the bearing and get our cam to fit. Oh, and then, we're gonna drill a little hole in the end of it so that we can use our cam bearing puller to pull that through the bearing. We're going to be doing that work on the lathe. This is actually the first time I've used the CNC to turn steel. You did a little bit of cast iron, I guess.
Yeah.
And
I
maybe
did some cast iron. That worked real nice.
Yeah, but you were running it all manual.
I was running it manual, so now you're doing it CNC
Yeah.
and steel, which is not going to cut as nice as that cast iron did.
Yeah. So anyway, over here, I'm going to have you start cutting out a few pieces. I think we want about 1 inch in the chuck and maybe a 1/2 inch extra from our total length of our part to the face of the chuck or to the jaws, just for some clearance.
Just
a little
kind
less
of safety factor.
Yeah, less pucker factor, if you will. And then, so total you need to be 3.5 inches, I think.
Okay.
This is some 1018 steel. I don't know if it's the right steel to work with or not, but
it's what we have.
That's what we have on hand. This is 2-inch diameter, so I'm gonna say you get set up.
Well, I've got it set up here so we can lop off 3.5 inches there.
Okay.
Are you ready for me to start?
Yeah. You guys go for it.
See if this old saw will work. There it is, started cutting. May take just a little bit. I think that blade's probably getting kind of dull, but it should cut that off.
How long have you had this saw?
Maybe 10 years.
10 years?
Yeah,
Okay.
it's a Harbor Freight special. I bought that when I was building some farm machinery. Just special to be able to cut out some pieces, and it's turned out to be quite handy for what it is. Getting close. There it is. First one. And there we have it.
All right, so yesterday we were talking a little bit about what we were going to be doing here, making, some broaches here. We decided to kind of turn off the camera. I mean, we recorded a little bit, but mostly focused on getting our process down without crashing the machine, since it's the first time we've ever actually ran steel in the new lathe. But we've got our number 3 broach done. And what's unfortunate is, to the eye, you have no way of telling that there is a little bit of a crown there. But
Right.
later on, we'll go in and we'll use the MC1 measuring center, and we'll show you that crown on the dial indicator there, and the micrometer actually measuring it. But I think we've got our process kind of figured out.
I think you've got it figured out.
Kind of gonna wing it here, but we'll start by, we're just gonna drill the holes manually because we're a little chicken on that part still.
Yeah.
And then we'll go through and make it and see if we can get the cam to fit.
See if we can make them go through the block.
So let's put this up in here.
Yeah, I'm quite impressed with the way it came out for being a first time try on that lathe. And you can, as I run fingers across there, I can feel just a little bit of crown in there.
So the one we're about to make is actually, what, about 20 thousandths smaller, I think, diameter.
Yeah, I don't remember without looking at the specifications on that.
I just want about 2.5 inches sticking out. So we're just gonna center drill the piece real quick. Okay. We're gonna drill a pilot hole before we go to our 3/4 inch drill. I don't have the right boring bar bushings to actually bore the center hole, so that's why we're using a drill, and it's a little tedious. They're in the drill bit. Okay, so we broke a drill bit, so that was fun. And whether it was the cause or the result, the boring bar holder ended up cockeyed. So I've gone through, recentered everything. Hopefully we can get back to going right through this. Okay, so we just kind of spot drilled it. Okay, so now we're gonna drill, hopefully successfully this time. I know there will be a lot of comments about how much faster this would be with the CNC.
Yeah.
Okay, I'm gonna re-aim the coolant. Now we have a pilot hole. Okay, so now we've got a 3/4 inch drill bit. Okay, well, I'm 2.3 there, so I should
You're
be
good.
good. I took our drawing from Fusion 360 and I have it in visual programming system here to draw the rough outline of what our shape is going to be. We got a lot of comments on the last video telling me to learn Fusion 360, the CAM package that's in that software, but I haven't had time to do that yet, so we're still using the visual programming system. I've done an OD removal cycle, and the plan here is to rough it out to within 10 thousandths of the final diameter for this part, in hopes that at that point we can measure it with the micrometer, see how we're doing, see if we need to fudge the numbers a little bit so that on our final cut we hit the diameter we want. So let's give it a whirl. Okay, get off your phone. You want to check my work?
I put my phone away.
Oh, okay. Well, that's new.
Well, it's always ringing right in the middle.
Okay, so the way we cut this, and if you actually come in here and look at it, this is our rough profile done. You can't tell it, but there is just a little bit of a crown there. I don't know, maybe the camera picks it up better than I think, but you can just barely feel it with your finger because it's about, what did we say, 5 thousandths?
5 thousandths is what you got.
This half-inch section here in the middle crowns up to a 5 thousandth higher than the outer shoulders here. But this was a rough cut, so the way that I had the machine programmed, we should still have 10 thousandths on the diameter to finish for a nice finish cut, even though even the rough cut left a pretty snazzy finish there.
If you run your fingernail across that, you can feel little real ridges.
Okay, but the way this is programmed on the shoulders here, which is where we want a little bit of clearance for the bearing to get the broach aligned, basically. Our final part needs to be 1.949 inches. So this right now should be about 10 thousandths bigger than that.
Yeah.
But I changed the insert since yesterday when we were first working on that other part.
Right.
So I was planning on doing this rough cut, measuring, and then we'll change our offset if we need to, so that the tool, compensates and ends up at the right diameter. So we're expecting somewhere around 1.959.
Right.
Okay, tell me what we got.
I have got 1.962.
Okay.
So you're 3 thousandths big.
Okay. Better than 3 thousandths small.
Right. But even at that, when you're 10 thousandths, shooting for 10 thousandths off, you've got some room to work.
Right. Okay. So 1.962. So what we need to do actually is change our offset here for that tool. Again, if you didn't watch the last video, this is our brand new CNC machine. I'm brand new to CNC. I'm not telling you that I know what I'm doing at all. This is just me learning through it, and feel free to comment about what an idiot I am. But when the machine thought that it was cutting at 1.959, it actually cut at 1.962. So I'm going to go into our offsets here. Right here you can see that I've ran it in on the x-axis to read 1.959. So the machine thought it was cutting 1.959. It actually cut 1.962. I'm going to go to our offset, and I am going to hit on tool number 1. I'll do X diameter measure, and we're going to change this to read a diameter of 1.962, right? Yep. Maybe a couple tenths different between the way I read the mic and the way my dad does. So now you can see that reads 1.962 here. And again, this is just me working through it in my brain, teaching myself. So I think we should be ready to do our finish cut. It'll actually be taking a 13 thousandths depth of cut, but we're going to run at 3 thousandths per revolution feed rate. So hopefully we'll get a nice finish here. My coolant is not even remotely close. There we go. Finish pass is done. You want to check that one? Or you been dinking around on your phone again? Or?
No, I have
Well, it's in your pocket. It's not over there.
Well, I guess I got caught. So, yeah, so I will measure this again here. And what were we shooting for?
1.949 on the shoulders.
And I've got 1.948 and looks like about 6/10.
Okay.
So we're 4/10 of an inch under what we were shooting for.
So I could have been a little more conservative when I changed the offset there, potentially. But with the way our specs are, I mean, you have a tolerance on that camshaft journal of 1,000.
Yeah.
The cam journal spec is 1.951 to 1.952. Mm-hmm. So we're going to be about 2 thousandths shy of the small side of the spec there.
Okay.
So that should be a good amount of clearance to get
the tool into the existing
bearing,
cam bearing.
especially if the cam bearing is tight.
Yeah.
Because there's the potential that the reason this won't go in is because the housing bore of the block was maybe a little,
right.
You know, the press fit of the bearing to the housing bore was a little tight and it actually kind of crushed it. The other option is if it's misaligned.
Yeah, if it's snaked through there.
But that should give us the clearance to get the tool started in the bearing and get it aligned well. And then I'm assuming we'll go in and check on the MC1, but I would just assume that our crown portion is also 4/10 smaller than we wanted it
and
to
it
be.
is. I've checked that.
Okay.
Yeah.
So it's about 53 and 5 or 53 and 6?
Yeah.
Okay, so that's still relative to our spec. That's, if the camshaft is on the big side of spec, that's still going to be 1.5-ish bigger. So I think that's a good spot to be in.
Yeah, I think where we're coming out is looking good.
I mean, we're within a half thou of our number that we set. That's a pretty reasonable tolerance for winging it.
Yeah, and that's what this is. This whole thing we're doing here is just yet one more experiment we're just winging it with to see how it comes out.
Yeah. So let's go eat lunch because I'm tired of not having food in my stomach. And we'll come back and we'll part this off, put a radius on the other side, and it should be good to
I'll
go.
be ready to pull those through the cam bearings and see if it works.
See if it works. Plan right now is we're gonna go in and part the part off, but since it's a heavy part, we're not gonna cut it all the way through to where it actually falls off. We're gonna leave about a 30 thousandths wall thickness, and then we'll come in and we'll cut it off manually with a hacksaw. Pucker.
When that thing comes across there, it always scares me when it goes across
Yeah.
the face. I'm like, oh, it's gonna crash.
I know. So this is another thing that, again, I've never been around a lathe. I've never been around a CNC. I don't know what the right way to part something like this off is, because it's a pretty heavy part. I knew that we don't want to just send our parting tool all the way through and let that tool drop into the machine because it's heavy. So more comment fuel for you guys. We're going to use a hacksaw because that's what hacks do. Probably. Okay. There's a little bit of a shoulder there that we got to take off. So I'm going to mount it in the chuck the opposite direction
Right.
that it was. We'll go in, we'll face, take the face off, and we'll put a little 80 thousandths.
Little radius so it looks just like the other
Yep.
side.
So then we'll have our number 3 and our number 4 ready to go, and we can try them in the block.
Okay.
So we faced the part again, we put a radius on it, so it should be ready to come out of here. That is our finished broach. And I can feel that raised part there, but I don't know if the camera will pick it up or not. With your eyes, you can just barely see that half-inch center section is a little bit higher. So now let's head into the other shop. Don't leave that in there. So this is the one that we made mostly off camera. I've got the MC1 set up here, so we used a 1-inch standard to set this, and now the micrometer is reading, it says 0.966, but you add an inch to that. We're just gonna rock this and find the high spot. Okay, so I've got it zeroed over here on this indicator. Our micrometer is reading 1.9657 inches. Again, we were shooting for 965 originally, so we're actually about 7/10 bigger than we were originally shooting for. But Dad and I talked, we thought that'd be all right. I'll flip it over and we'll check the shoulder on the opposite side. And you can see as I rock it there, comes to the exact same 0 spot on the indicator. So that tells us we don't have any taper from side to side. But now I want to show you guys where that crown is in the center of the part. So I'm just going to start raising this up, well, lowering the table, but we're measuring higher up. And you see this needle moving up. I'd say that's about the high spot. So I'm going to, and one thing to note, that's at exactly 1 inch the way this indicator up here reads. It's telling us that we're measuring exactly 1 inch from the bottom of the part, which makes sense because it's supposed to be a 2 inch long part and we wanted the high spot to be right in the middle. And again, we were shooting for 1.970-ish, and we're 1.970 and 4.5 tenths. So within a 0.5 thousandth of the number we were shooting for. In this case, on the bigger side. We've sized everything off the smaller side of the spec. So
Right.
with that, you know, if the camshaft is on the bigger side of the spec, that would be about 2.5 thousandths bigger than what the camshaft will be when we pull it through the through the bearing. So let's go ahead and check the one that we just made. Here I'm getting 948.1. Okay. So maybe closer to 1,000th off from what we were shooting for. Let's check this side. Maybe a 1/10 different. 948.2. So we were shooting for 949, so there we're within 1,000th. A little bit smaller on this one. Check the crown again. There our crown started. And again, it's roughly 5 thou higher and within about 15 thousandths of 1 inch high in the center of the part there. And this one came out at 953. So if the spec is 1.951 to 1.952, we'll be between 1 to 2 bigger.
Yeah, 1 to 2 bigger than what the bearing is supposed to measure.
So we could potentially make another one and be a 1,000th bigger.
Yeah, if we had to. But we'll
we're
try
gonna
this
try
first.
this and see what it does. But let's go out to the shop and let's polish this. Make
Yeah,
it
we'd
nice.
like that be just as smooth as we can make it.
And we might have to hone the ID of it to make it slip over the bar on our puller, because the bar itself is 3/4 of an inch, and so is this hole. So we
Yeah,
need
we need a little bit of clearance in there. Our bar this goes over is exactly 3/4 of an inch, and we drilled exactly a 3/4 inch hole inside our little broach here, and it's draggy. It won't quite go on as smooth as it could. So I'm just gonna hit it on the hone here. Maybe take out a couple thousandths. Might not even be so much take that much out as it is. It just kind of takes the burrs off. And I'll bet with that right there, this will probably slide right in. That's all it took.
So the other day, we put 1, 2, and 5 in.
Right.
Cam spun amazing. We put 3 in, and
It started getting a little bit snug. It probably would have been okay, but didn't feel,
didn't feel great.
yeah.
Put 4 in and couldn't even
Yeah.
really get the cam in all
No,
the way.
it was too tight.
So whether it's an alignment thing or whether 3 and 4 are just screwed up, can't tell.
Let's just pull our tool that we made through number 3, and then let's do number 4, and let's see how the cam fits. See if
Okay.
it changes at any.
Okay, so here's the one for number 3,
Yeah.
and we're gonna use the assembly grease, just so it's nice and oiled up. Are you gonna put some on?
I'm gonna put some in the bearing. You want some on there?
Yeah,
About like that.
probably so.
Do all we can to make it slide through as easily as it can, so it actually displaces material instead of dragging it through, yeah. Don't tell me you can't get it in there with the grease on it, because it went in without grease on it.
Like, went in much harder with the grease on it. Okay, but
I see it. That's a close fit.
yeah, it fits really nice, actually.
Yeah.
The other one will be a little bit looser than that, but that's a pretty nice fit there. So now, let's set up the puller.
Anyway, hopefully you can see that the tool does slide into the bearing.
So the idea there was that it pilot the,
Pilots itself, gets itself started straight, and then now that it's come to the raised portion of that tool, it's tight. We've never done this before. We don't know how hard that's going to pull, so I don't know if this puller will do the job for us or not. If it doesn't, we can always drive it through with our old style cam bearing tool.
so do you have any concern, Josh was asking, do you have any concern about it pulling the bearing through?
I have thought about that, but I don't think it will.
Okay.
I think there'll be enough friction that the tool will easily go through the bearing before it actually just grabs the bearing and pulls it. And again, that's why we polished that
Yeah.
mandrel we made there and greased it up good with some high pressure lube.
I'm just gonna start pumping here. It feels like it's gonna move right through
Okay.
so far. It doesn't even feel like it's
Okay. Well, that's
anything there.
good.
And we should be able to get to where I can pull it out and it's not gonna drop and screw up our other
Oh.
bearings, right?
Well, since we put the pilot on both ends,
Should be able
once
to.
you're through, it'll still be piloted in that bearing.
I'd say there it was.
Yeah, that went through a lot easier than I thought it might. Pull your tool out. Or pull it, yeah, that's okay. I was gonna say you could stop there and we
Well,
put
we
the
need,
other,
we need to grease up the other one.
yeah, that's right.
So it made the bearing pretty shiny.
Well, that's good.
And that's kind of what I've heard is like any high spots, it'll make, kind of shiny there. This one's probably going to go through like butter because it's even a little smaller than, well, unless the
Unless the bearing
bearing
itself
itself
is,
is tighter. So I'm going to drop this one down in. Okay, so there it's up tight. Again, it's a real nice fit.
okay, let's go for it.
Okay. There it is, right? Yep. Just make sure my bar doesn't.
There.
Again, kind of just a little bit shinier all around.
Pronounced right by the oil hole.
Yeah. So if it doesn't fit this time, do we make one more of these a little bit bigger for number 4?
I think that's probably be a good thing to try.
Okay.
As easy as that went through there,
Yeah.
before we move on to trying anything else. Okay, let's see what that feels like. That did it.
Holy cow. And it feels good?
Considering there's no lube on it right now, I think it feels pretty good. Amazing.
So the question is, do we want to do the next size, a little bit bigger one on there?
For the most part, any engine I ever built, if I put the cam bearing in and I could turn it by hand, I felt like it was fine.
Okay, so rather than going straight to using the material and the time to make another broach, we're just going to run it through twice.
Yeah, let's run it through a second time, see if it changes it any. Yeah, may not take much because we're real close. You know, once you get that greased, if you used to drop it, let it roll around the floor a little bit, pick up a little bit of grit, and then run it through, that'd probably broach it.
Sure, that's what some shops do. See, because it's still tight enough that I can't just push it through. So theoretically, this might be enough.
Might be just enough to make the difference. How's it feel this time compared to the first?
About the same. I mean, pretty much no resistance, but more than no resistance.
Yeah. You there all the way?
Yeah, I think so. Take it off and see.
Yeah, it is. Let's quit right there.
Okay.
Yeah, anytime you have a cam that you can turn that easy, it's going to be fine.
And there was one bearing that we wanted to look at how they were aligned, but I look in here, I'd say we're lined up pretty well relative to all the journals.
Front to back, they all look good.
Yeah, the cam bearing itself relative to the journals.
But yeah, look how nice that turns now. I'm happy.
So that is how you avoid thousands of dollars in labor
Yeah,
of line boring your cam tunnel on your Chrysler block.
we need to take the time here at some point and make 3 more of those for the other 3 cam bearings.
Or do like we discussed and make one long bar that has the journals at the correct sizes and distances, and you'd have to, well, you could rig up a puller, I guess, to still pull it through, or
Yeah.
you could just drive it through gently.
Yeah,
And do all 5 of them at once, and then you'd have to push
Pull
it
it back.
the other direction since
Which
they're
is fine.
stepped. But it'd get broached twice or
Yeah.
whatever, just like we did on this one, and I bet that would.
put that on your list of things we need to do.
I think. Yeah, I can't think of something funny to say, but that's a long list. I think.
It's getting to be a long, long list.
I think it starts right after that car over there.
Do you feel a sense of accomplishment?
I feel like that lathe is paying for itself.
What are we down to now per part cost?
10,000.
No, we're past that.
3.
We're
I
down
don't
in
know.
we're down into
Well,
the
this
hundreds.
year saved us. These 2 parts saved us a couple thousand, so I'm happy.
Yeah.
On to the next one.
You